welcome back to the channel. And first of all, a heads up, 30 LEDs, tiny little ones, $1.25. These string lights are in Dollar Tree at the moment, and they come with, well, I'll show you this one. They come with the battery case, on-off switch. Normally 2 batteries go in, but of course I did the right thing and made a Joule Thief kind of a circuit, and now this one will run from just one of those AAs. And I thought to myself, I want to push this a little bit further. Can I make, and I don't know yet, but can I make a homemade cell to run these instead of a battery, and ideally to be rechargeable, and try and use it as some form of garden light, because 30 LEDs strung out could look quite nice. So that's going to be the project, and here are the parts to make up my own cell. And what I'm going to be using is alum. I'm going to mix some in this rainwater. I'm going to use a piece of lead from this old battery here. That battery must be about 15 years old now. And you can reuse the negative plates. It's the positive plates that corrode. So I'm going to use a pair of pliers to pull pieces out. So I certainly wouldn't use my hands, bare hands, certainly wear gloves or whatever to do such a thing. But in this case I use these pliers. Got some lead out. And then on the positive electrode, I'm going to be using the inside carbon, a carbon rod from inside one of these, well, this old AA. And yeah, I made one, gosh, it ran for 7 years, and it was carbon lead. And I think the reasoning was why nothing happened to it whatsoever in terms of corrosion is because normally you've got a sacrificial plate. If you've got 2 metals, one of them will corrode. Same thing with the lead, you know, the positive plates go. But in terms of this, it's carbon and nothing happened to it in the 7 years, and it kept running an oscillator all that time, 24/7, absolutely no issues. So that's the kind of thing I'm going to make. So the next thing to do is to put some alum into that water. I'll not need a lot because I'm thinking of making a kind of flat design of battery cell. Right, so let's get some of this in here. This alum, there's not a lot of it left, but I'll use probably half of it. Well, I'm just going to tip some in. There we go. Not a very strong solution, but that's about half of it. Exacting measurements, hey. And now, well, shake it up, get it to dissolve some, and that'll be that. Now it is fairly well mixed, but one trick to fully dissolve alum is to warm it up. So if the sun bothers to come out, I'll leave it out in the sun for an hour or so. That'll heat things up and that'll dissolve it. Saves using the microwave anyway. Next is to take this battery apart and get the carbon rod from inside. I'll just show a couple of pictures of that as I do it. Right, so there they are. That's the positive and the negative. I've also washed this in the sink to get rid of any, well, remaining stuff around it. The next thing is going to use this kitchen roll, wrap that around, and I'm going to dip the whole lot into this solution. And then I think I'll put some cling film around the construction to form the battery cell. And hopefully we'll have a rechargeable carbon lead battery cell. Right, so there it is made. You can see there's only a slight gap. I might actually put some cardboard in there to make sure they never touch. There's the piece of press and seal. I have decided to use a piece of cardboard, so I'll just put that between the two. Then I'll dip it in, and then I'll put that round. And there we are, it's completed. I really didn't use much of that, did I? But anyway, so now I'll just get a quick voltage reading, see what it is as it stands. And the answer to that is, let's have a look. Oh, that's alright, isn't it? 0.98, so basically 1 volt. Okay. So that's made me think that it should run an oscillator fairly well. This is a blocking oscillator here. And if I connect up the negative, yeah, there we go. So there we are, flashing away, uncharged. And I do remember charging the other one back at the other house. I don't know when, but I don't think it was right at the start. Anyway, this one's now running. I'd imagine it'll just run all the time until that dries out. So yeah, very pleased with that. And the next thing obviously is to see whether it runs with this thing and all these LEDs. That could be quite exciting to see. That's next. Try it uncharged. So I've taken the AA out now, and I've also connected up the positive. I haven't connected up the negative, so you're going to watch with me, and let's see, do we get anything? Oh, and the answer is no. No, there's not enough to run that. So what I'm going to do next is, I don't know yet, I'm going to use two AAs. I'm going to put 3 volts into this for about half an hour, see if it charges up. The whole idea is to use a solar panel, of course, but I may have to form the plate, not sure yet, don't really know, but I'm going to use 2 AAs. In fact, I might modify one of these things and put the 2 AAs in that. Anyway, half an hour, and then try it again and see if we can get a result. So there we go, all set up. There's now 3 volts going in, hopefully charging up that cell, and it's showing 3.15. So I'll come back in half an hour, I'll then disconnect from this and see what the cell says. Right, it's been about half an hour now, and 2.79 left on the batteries, so hopefully that means this has taken some in. Let's disconnect, and the cell itself is coming down from about 2 volts. Right, so the next thing is going to be, is it powerful enough to run those lights? Well, let's hope so. No, it's stabling out to about 1.8. That's a pretty good result. So the big question, will it run those lights? Well, you'll find out when I do. There's the positive. Okay. Oh, look at this. Look at this. There we go. It is running them now. So it has kept a charge. Oh, wonderful. Well, there we are. So that's the basics there of how to make a cell that will charge up. And the next thing to do, I guess, would be to put a solar panel on and see how that does. But I'll leave that for another video, because I don't know how long this will run for on this cell on this first charge. Okay, well, I've had this running for a few minutes now and there's no change. Those lights are on all the time. When things get low, then this kind of blocking oscillator circuit, which is basically a Joule Thief, will start to make them flash. And yet, no, these are on all the time, so it's going to be interesting to see how long they do last. I'm very pleased with this cell though. That's running well. I've just thought to put this radio based clock at the side. Anyway, it's 9:38 now, and it's still looking pretty good. It doesn't seem to be flashing to the eye, like I say, so if we see it about, 26 frames a second and the camera does 30, would I be right in thinking that must be flashing at 28 times a second? I don't know, it's getting late in the day. It's now 10:05 and these are still going. As I say, I can't see them flickering to the eye, but they seem to be on this screen. But yeah, I'd say, 10 o'clock, decent run, hopefully get to 11. But for an evening, that's pretty good. Okay, it's now gone 10:30. There's been no change in this evening. As I say, I can't see them flashing, but they are on the screen. Alright, it's gone 11 o'clock and it's still running, and it's running in the same way as it has done for hours now. I can't see it flickering to the eye, but I can see it on the camera. So yeah, that's a good evening run. I'll be off to bed shortly. That's successful. Okay, thanks for watching, and I'll see you next time.